Hi everybody. Okay, so this is the second example that we're gonna, or the second part of parabolas. We actually will be our first example. So in the first video, I talked about what a parabola was, and we derived the equation for parabola with a vertical axis of symmetry. We're going to actually do an example where you have a parabola with a vertical axis of symmetry, but I do want to talk about what happens if the vertex is not at the origin. So let's say we've got a parabola, and instead of the vertex being at the origin, we're going to let the vertex be anywhere else. Let's say right over here in the first quadrant somewhere. And we're going to always call the vertex the point HK. Alright? The properties are going to stay the same. We said that let's put our vertical axis of symmetry right there. And we said that our focus is a distance p away, and it still will be a distance p away from my vertex. Okay, what gives us this coordinate right above there, that h is going to stay the same because this is a vertical line, but my y value is going to change because I'm going to go up p units from this point. So if the y value here is k, then the y value for that point is going to be k plus p. So we have this coordinate now for this focus to be h, comma, k plus p. So for my directrix is going to be p, distance p down from that coordinate. It's going to be a horizontal line, so it's going to be y equals something. It's going to be y equals k minus p. So let's put our directrix, let's say, down here. So the equation for this directrix is going to be y equals k minus p, because I'm going to be moving p units down from that point. Okay? Now, if you remember in the last video, I said that for vertical axis of symmetry and vertex at the origin, we had x squared equals 4py. That is not this case. This case has a vertex at hk. So simply the only thing I'm going to change here is wherever I see an x, I'm going to put in x minus h, and wherever I see a y, I'm going to put in y minus k. This is going to be true for all my conic sections when I start shifting either their center or vertex away from the origin. So this becomes x minus h squared equals 4p times y minus k. This is the equation for this parabola that's centered at vertex at hk with a vertical axis of symmetry. Now that we have this format, we can always find the focus to be at the point hk plus p, and the directrix is going to be at the line y equals k minus p. Alright? Now notice this general form works even if my vertex was at 0, 0, because if I put in 0 for h and 0 for k, I'm going to end right back up here. Okay? So here we go. We're going to do a problem, and this one's going to be a little bit complex. We're going to be given an equation, and we have to put it in this format and try to get the directrix, the vertex, and the focus off of that formula. Okay? So here we go. We have x squared plus 6x plus 4y plus 25 equal to 0. Now this is a very complex problem. There's a lot that needs to be done to it. The first thing I want to do is it's always about getting it in the right format. So the first thing I'm going to do is I'm going to try to get it to look just like this. Okay? Because once I have it in this format, then I can pull off my h, my k, and my p, and those are the pieces I need to find all those parts of my parabola. Now, this has it's kind of messy. So what I need to do first is I want this to be a perfect square trinomial on this side. So I'm going to move my 4y and my 25 away, because I'm going to force a perfect square on the left side of the equation. So this is going to be x squared plus 6x equals negative 4y minus 25. People always get scared when they hear, perfect square trinomial, because they think, oh, completing the square, that's going to be horrible. But it's really not bad if you just remember the simple property is, if let's say, notice here my leading coefficient is 1, that's the first important rule. When we get to hyperbolas and ellipses later, we'll talk about that being an issue, but for my parabola it's going to be fine. So I got my leading coefficient as 1. What I want to do is I have to say, what do I add on to this to make this a perfect square trinomial? So it's always going to be the case that I take half of my linear coefficient, which is going to be 3, and square it. I'm going to add that over to 9. Okay? That's what I'm always going to add on to make a perfect square trinomial. Half of my linear coefficient and square it will always force us to be a perfect square trinomial. Now we know if I add 9 onto this side, I've got to add 9 onto this side. Okay? Now when I say it's going to make a perfect square trinomial, if I go to factor this, this is going to factor as x plus 3 times x plus 3. And that's what we mean by making a perfect square trinomial. And then if I come over here, I end up with negative 4y minus 16. Now, I'm not quite finished, because if you look up here, I've got the left hand that looks correct, but if you notice here, you might go, well, oh, I see 4p, so p must be y, and this is kind of a mistake that people make. No, I've got to have it looking like y minus or plus some number like this. I'm not there yet, which means I've got to factor the negative 4 out so I can make that format match. So when I factor out that negative 4, I end up with negative 4 times y plus 4. Be careful there, that's actually where I usually make my mistakes, is I'll forget to change that sign. So now I'm looking right at this form right here. So I'm going to actually rewrite that up underneath here. X minus h squared equals 4p times y minus k. So we can kind of really look at that and see what our components are. So that means that h must actually be negative 3. Notice this, it's x plus 3, right? So the only way that could have been a plus is for it to have been a double negative. So we know h is negative 3. Now if you look here, 4p has to equal negative 4. So I'm saying, what do I multiply 4 by to get a negative 4? P must be negative 1. A lot of times, if that leading coefficient, that number in front is 1, like that, people will think that p is 0. P is never 0. If you don't see a number in front, then p must be 1/4. Okay? And then last, we look at our k. K is going to be negative 4. Now sometimes people will forget to change those signs when you pull it out, but just remember those signs are always going to switch from whatever you see inside the parenthesis. When you pull it out, those signs will always switch. Okay? So here we have our pieces. So that was majority of the work of the problem, was just getting it in the right format. So our focus, as we said earlier, is going to be hk plus p. So h, which is negative 3, k, which was negative 4, plus p, which is negative 1. So that's negative 3, negative 5. Our vertex is hk. I always remember it as x, y, everything goes in alphabetical order. So h comes before k, x comes before y, so I know they go together, so h and k are my x and y. So we get negative 3, negative 4. And then last, my directrix is going to be y equals k minus p. Oops, okay. Y equals, k is negative 4 minus a negative 1. So be careful with signs here. That can be, the arithmetic can be a real killer on these problems. Y equals negative 3. Okay? So this was about as hard as you get as far as parabolas go. As far as putting it in the right format, you have to complete the square to make that look nice and pretty, and then pull those values out. Just be very careful with those signs. That's where the biggest problems lie for most people. Good luck with this concept.